Rogue planets, those elusive and free-floating celestial bodies that drift through the cosmos without orbiting a star, present fascinating possibilities for travel in our galaxy. However, their inherent dark nature makes them challenging to detect among the brightness of more prominent stars. Recent discoveries, particularly from a cluster of young stars in the constellation Scorpius located just 420 light-years away, identified at least 70 rogue planets, though estimates suggest the number could be as high as 170. If we extrapolate this data to the entire galaxy, we might be looking at over 50 billion rogue planets. The concept of utilizing these rogue planets as spacecraft is intriguing, but catching one poses significant challenges. These interstellar taxis are not like earthly rideshares. They typically zip past our solar system in just 3 to 4 years. This means we'd need to be incredibly prepared, as hanging around too long could leave us waiting another 10,000 years for another opportunity. Currently, our technological capabilities would struggle to reach even Jupiter with any spacecraft we have today, and a rogue planet may fly by far beyond Neptune's orbit. To take advantage of this unique travel method, we'd need a fleet of fast, spacious ships ready to transport passengers and their belongings efficiently. Interestingly, one proposed workaround involves using a dwarf planet, such as Sedna, as an intermediary transport. By equipping Sedna with powerful jet engines, we could potentially ferry ourselves from the inner solar system to the outskirts where a rogue planet might be passing through. However, Sedna itself isn't habitable, and neither would many rogue planets be. The two primary hurdles for human health during long spaceflights are the effects of zero gravity and high levels of radiation. In theory, if we could land on a rogue planet the size of Earth, we might counteract gravity-related health concerns. If it lacks a magnetic field, we would need to construct underground shelters to shield against radiation, likely beneath layers of ice, as many rogue planets would be cold worlds similar to the fictional Hoth from Star Wars. The majority of the rogue planets we've found so far are gas giants, akin to Jupiter, and although they typically have robust magnetic fields to help protect against cosmic radiation, passengers would still need supplementary protection in a spacecraft or space station, creating more zero-gravity challenges. We'd also face the necessity of energy sources for sustaining life and agriculture, as rogue planets are far from the warmth of sun-like stars. Thus, bringing along thermonuclear reactors for energy would be imperative to support both humans and crops. Ironically, this scenario leads us back to constructing an ordinary spacecraft equipped for interstellar travel rather than relying on rogue planets. But the author of this speculative travel plan insists there is something unique about rogue planets: their extraordinary speeds. Many rogue planets can travel at over 70 kilometers per second or more, while even the fastest human-made spacecraft struggle to achieve much higher speeds. However, the reality remains stark. Even with the speed of these rogue planets, traveling to the nearest star system like Alpha Centauri would still take thousands of years, over 6,500 years at even the best speeds. The journey would span generations, with many potential travelers not living to reach their destination. Additionally, the erratic trajectory of rogue planets makes planning a stable route exceedingly difficult. So, if you're considering modifying a rogue planet with engines for navigable travel, it might just be simpler to stick with traditional spacecraft. In the end, while rogue planets offer a thrilling concept for interstellar exploration, the practical realities often lead us back to the drawing board.